Okay, so this video is going to be for the Arty A7-100T board. It's like a very small board. It costs about $300 from Xilinx website. And I'm going to make a simple AND gate using VHDL. Then I'm going to wire it up to the board and show you a live demo. So start things off, create a new project, pick the appropriate board part. If you don't have it, make sure you download it. Then, okay, I'm going to skip ahead to where we are right now. We're going to add something called Magic Mux. That's just a funny name I came up with. You're going to pick the language of VHDL, and you're going to not specify any inputs right now. Just click yes, 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 okay. Then the source file is going to appear. You're going to double click on it to open it. You're going to go down to the ports. Well, I like to clean up the extra comments. So I'm going to paste the ports in. So there are 4 switches on this board. I'm making 4 inputs for switch A, B, C, and D. There are 4 LEDs. I'm not talking about the RGB LEDs. I'm talking about the regular ones. So I'm going to name these LEDs 0, 1, 2, and 3. Then the implementation is very simple. LED 0 equals switch A. LED 1 equals switch B. LED 2 equals switch C. And now for the last one, we're going to do something different just to prove things out. We're going to AND switch A, B, C, and D. Okay, so everything looks fine. So now we're going to create a block design. Keep it at the default name to keep things simple. You don't want to rename it because somewhere else you're gonna run into problems. Not necessarily, of course, but in my recommendation. So once you have the block design open, wait a couple of seconds for it to initialize. Drag your VHDL source code onto the thing. Then right-click on the IP and put Make External. It made every single input and output port external. Now you're going to right-click on the design and click Create HDL Wrapper. You want to let Vivado automatically manage this file, and it's going to name all the inputs and outputs of the wrapper exactly what's on the block design. So now if you open the wrapper, you can see how the design is embedded inside of it. And then in the design, you could see how the Magic Mux VHDL code is embedded as well. So now we're going to create a constraints file. Doesn't matter what you name it. You're going to go on GitHub and you're going to find the master constraints file for your board. So this board is the Arty A7-100. And GitHub has this new feature now. You just click copy next to raw. Copy the entire file, paste it in. Now we're going to scroll to the top and we're going to look for the switches and for the LEDs. Towards the end, you'll see SW 0, 1, 2, and 3. We're going to rename that to what we used in the actual design. Switch A, switch B, switch C, switch D. Then we're going to go down to the LEDs, not the RGB LEDs. And we're going to do the same thing for the 4 outputs. And notice how the name is LED underscore 0 underscore 0. That's just added there by Vivado. It's not the end of the world. We're going to go back to our Magic Mux, back to our diagram. Oh, look, switch A underscore 0. So we have to go back to our okay, this is going to fail, but I can show you how we debug errors. So you have synthesis, you have implementation, and you have simulation. Notice how there's no error in the synthesis. Now we click on, I don't know why I clicked on it again. Now if you go in implementation, you're going to see the error. Unspecified I/O standard for 4 out of 8 logical ports, unconstrained logical port. That's saying basically it doesn't know what to do for LED. Is it LED or is it's the switch? So you scroll up. It doesn't know what to do for SWA because there is no SWA. So I'm going to put the _0 at the end. Now I'm going to save and run generate bitstream. I'm going to fast forward the video a bit here because it takes a couple of minutes. All right, so now we can open the hardware manager. Make sure your Artix A7-100 is plugged in. Click Open Target Auto Connect. If it's connected to your machine, it should find it. Then we're going to right click on the chip itself and say Program Device. And that's it. So now see how I just ran Program Device, and here is my Arty board. I'm going to move one switch, look at one LED light up. The next switch, the third switch, and the fourth switch. Now remember, the fourth switch is an AND of all four, so if I enable any of them, the fourth switch will turn off. And that's it.